Today we are going to deal with a class of compound which in some way or the other determines the economic growth of a country and thereby measures the wealth of a nation. This class of compound is familiar to all of us for its use in various fields, starting from its action as an industrial solvent, medicinal use, beverages, and also as an additive in petrol to increase the combustion efficiency. Moreover, we all have experienced the strictest of the lockdown in the past few days. And during this, some of the essential commodities simply ran out of the market. However, in the recent times, if the market share of any commodity that has grown massively, then it has to be sanitizers. Now tell me, what is a major component of a demanding sanitizer? Yes, you got it right. Today we are going to discuss about alcohols. The name of our chapter is Alcohol, Phenols and Ethers. We are going to start with alcohol. What are alcohols? Alcohols are organic compounds whose molecules have one or more hydroxyl group attached to a carbon atom. They are represented by general formula ROH. See, here we have an alkane RH. So this H of an alkane is replaced by OH. So ROH is an alcohol. So alcohols can be termed as hydroxy derivative of an alkane or rather hydroxy derivative of a hydrocarbon. Now this molecular structures with more than one OH group attached to a single carbon atom are generally not stable. However, an alcohol molecule can contain two or more OH groups, and if this OH group is attached to a different carbon, then the alcohols are stable. Accordingly, alcohols are classified as monohydric, dihydric, trihydric and polyhydric. So what is the basis of this classification? This classification is based on the number of OH groups present in the alcohol. Let us see the first alcohol, that is ethyl alcohol. In ethyl alcohol, only one OH group is present in the alcohol. So ethyl alcohol is termed as a monohydric alcohol. Now let us come to ethylene glycol. In ethylene glycol, we can see that two OH groups are present. So this alcohol is termed as dihydric alcohols. Now what is the IUPAC name of ethylene glycol? The IUPAC name of ethylene glycol is 1,2 ethane diol. Now what is the use of this ethylene glycol? Now this ethylene glycol is used as a very good antifreeze. Secondly, ethylene glycol is also used in the manufacture of terylene and other polyesters, which are used for making synthetic fibers in textile industry. Now, what is the test for ethylene? How we have tested ethylene in the lab? Now, when ethylene is treated with cold dilute alkaline KMnO4, then the pink color of alkaline KMnO4 is decolorized. Now, why the pink color of alkaline KMnO4 is decolorized when it is treated with ethylene? It is due to the formation of ethylene glycol. So ethylene with alkaline KMNO4 gives ethylene glycol. And this test is known as Bayer's test. Now let us come to this trihydric alcohol. What is the IUPAC nomenclature of this trihydric alcohol? This is 1, 2, 3 propane triol, and its common name is glycerol. Now in glycerol we can see that there are 3 OH group attached to the different carbons. So this is termed as a trihydric alcohol. Now this glycerol is a viscous, colorless, hygroscopic, syrupy liquid. The highly viscous nature of this glycerol is due to the presence of 3 hydroxy groups. Due to the presence of these 3 hydroxy groups, glycerol undergoes extensive intermolecular hydrogen bonding and forms associated molecules. This is why it has a high viscosity, even higher than that of ethylene glycol, which possesses only 2 hydroxy group. Now, what are the important uses of this glycerol? Glycerol is used for the manufacture of nitroglycerin, which is extensively used in the manufacture of dynamite. Glycerol is also used as a sweetening agent in beverages and confectionery. Now this glycerol in the commercial form, that is glycerin, acts as a very good moisturizer for the skin. Now let us come to this polyhydric alcohol, sorbitol. Here 1, 2, 3, 4, 5, 6 hydroxy groups are attached to different carbon atoms. So the alcohols where more than 3 hydroxy groups are attached to different carbon atoms are termed as polyhydric alcohol. Now we will discuss the monohydric alcohols, in which the OH group attached to all the carbons are sp3 hybridized. In this class of alcohols, the hydroxy group is attached to a carbon atom, and these carbon atoms are all what? sp3 hybridized. Such alcohols, like the alkyl halides, are further classified into 3 groups. That is 1 degree alcohol or primary alcohol, 2 degree alcohol or secondary alcohol, and 3 degree alcohol, that is tertiary alcohol. This classification is based on the degree of substitution of the carbon to which the hydroxy group is directly attached. If the carbon atom has only 1 carbon attached to it, then this carbon is termed as a primary carbon. Now the OH group attached to a primary carbon or 1 degree carbon is termed as 1 degree alcohol or primary alcohol. Now if the carbon atom that is attached with OH is itself attached to 2 carbon, then this alcohol is termed as a 2 degree alcohol, and this carbon is a 2 degree carbon. Now the alcohol in which the OH is attached to a carbon and this carbon is attached to 3 other carbon, this type of alcohol is named as 3 degree alcohol. So this carbon is a 3 degree carbon. 3 degree alcohol can also be termed as tertiary alcohol. Now let us see the IUPAC name of all the 3 alcohol. The IUPAC name of this alcohol is ethane-1-ol or ethanol, and its common name is ethyl alcohol. Now the IUPAC name of this 2 degree alcohol is propan-2-ol, and its common name is isopropyl alcohol. The IUPAC name of this 3-degree alcohol is 2-methyl-propan-2-ol and its common name is tertiary butyl alcohol. Here we have the structure of benzyl alcohol. The sp3 hybridized carbon atom, which bears the OH group, is attached to an aromatic ring. So here it's benzene ring. So this is the structure of benzyl alcohol, and benzyl alcohol is a monohydrate alcohol. Let us come to this allylic alcohol. In allylic alcohol, this carbon which is attached to OH group, this carbon is sp3 hybridized, and this sp3 hybridized carbon to which the OH is attached is next to a carbon-carbon double bond, and this is known as allylic alcohol. Let us now see vinylic alcohol. In vinylic alcohol, the carbon atom which bears the alcoholic OH group is sp2 hybridized, and it is attached directly to carbon-carbon double bond. Now let us discuss the preparation of alcohols. The first method is the hydrolysis of alkyl halides or haloalkanes. Number 2, from Grignard reagent. The third one is hydration of alkenes. The fourth one, reduction of carbonyl compounds. And the last one is from primary amines. Now let us discuss the first method of preparation of alcohol, hydrolysis of alkyl halides. Alkyl halides in the presence of aqueous KOH or aqueous NaOH or moist silver oxide, that is AgOH, undergoes hydrolysis to give us the corresponding alcohols. Rx, that is alkyl halides or haloalkane, undergoes hydrolysis with aqueous KOH to yield ROH, that is alcohol plus KX. Now the mechanism of this reaction is nucleophilic substitution reaction. Now it can be either SN1 or SN2. That will depend on the nature of the R group, polarity of the solvent, temperature, etc. Now this alkyl halide, that is Rx, reacts with moist silver oxide to give us alcohol ROH plus AgX. Similarly, ethyl iodide undergoes hydrolysis in the presence of either aqueous KOH or aqueous NaOH to yield ethyl alcohol. Now, this hydrolysis of alkyl halides, this is a very good method for the preparation of alcohols from 1-degree alkyl halides or primary haloalkanes. Secondary haloalkanes undergo simultaneous dehydrohalogenation, that is elimination, and give a mixture of alcohols and alkenes. So secondary haloalkanes will yield alcohols by substitution reaction, and they will yield alkenes by dehydrohalogenation reaction. Tertiary haloalkanes mainly undergoes elimination, that is dehydrohalogenation, and give mainly alkenes. Now let us see this haloalkanes. This is tertiary haloalkanes. This tertiary haloalkanes reacts with NaOH to yield this alkene plus NaBr plus water. Now, what is the name of this alkene? It is 2-methyl-prop-1-ene. So this alkyl bromide, which is tertiary alkyl bromide, when heated with aqueous NaOH, it will give alkene as the major product. That means tertiary haloalkanes are undergoing mainly elimination reactions or dehydrohalogenation reaction. Now this much for today. In our next class, we will learn the other methods of preparation of alcohols. Thank you.